Okay, I'm going to assume that everyone did the homework, so you have to mark your work. Okay, you have to mark your work. The first question was d of x of x cubed minus 2x squared minus x plus 2 all over x plus 1. Okay, that was the question. Now, for you to be able to do the question, I hope that you all saw this. The numerator of this fraction is a cubic polynomial. Okay, now you can factorize this by grouping and also by taking out a common factor. So before you find the derivative, you're supposed to factorize the numerator using a common factor and grouping. So your next step will be d of x of x squared times x minus 2 minus x minus 2 all over x plus 1. Okay, so this was supposed to be your first step. If you could not factorize the cubic polynomial, then it was going to be very difficult for you to find the derivative. Okay, then I'm sure you can see here that we have a common factor, which is what? X minus 2. So our next step will be d of x of x squared minus 1 times x minus 2 all over x plus 1. Okay, it's simplified, yes, but we still need to eliminate this denominator. Okay, the only way we can eliminate, we can see here we have got a difference of 2 squares. So we'll factorize this, the difference of 2 squares. If you factorize, you get d of x of x plus 1 times x minus 1 times x minus 2 all over x plus 1. Okay, so this x plus 1, let me use a different color. So that x plus 1 and that x plus 1 will cancel out. Okay, when they cancel out, you end up having a new polynomial which I am going to expand, that is x minus 1 times x minus 2. So you get d of x of x squared, so you get minus 2x minus x, you get minus 3x plus 2. Okay, so your final polynomial which can be differentiated, okay, by the way, the act of finding a derivative, you can also say differentiate. So here we can now differentiate this polynomial. Okay, so the next step, but I think I can do it here. Right, so your final answer will be 2x minus 3. Okay, how many of you got this answer? Raise your hand. I just want to see. You said what happened?
The signs.
You made a mistake in terms of the signs. Okay. All right. At least most of you got it right. Thank you very much. All right. Let's get on. Let's get on. Is there anybody who has got a question? I hope you can see the way that I'm doing this type of a question with the differential operator. The differential operator must be on the right-hand side of the equal sign, not on the left-hand side. It must be on the right-hand side. At the instant when you decide to differentiate, you stop writing it. Yes?
Does it matter where we stop? Let's say I stop at the second step and 2x minus 3. Does it matter?
Okay. What do you mean by that? You're talking about stopping here.
No, so like, does it matter where I stop writing dx?
No, you see, this subject has got specific ways of doing things. So you need to follow those things. Right? That's why you need a teacher, right? To guide you correctly. Okay? So the differential operator, when you are using it, okay, you carry on writing it down until that point when you decide to differentiate. That's when you stop. Okay, I'm saying that because if you do something else, then I'm not your math teacher. All right, let's carry on. The next question. Don't do your own things. Okay, every subject has got its own rule, it has got its own notations, and so on. So you must follow those rules and notations. So here we have d of x of the square root of x over 2 plus 2 over square root of x. Do you know that if you go to university and then you start writing wrong things that we are teaching you now, that the lecturers will ask you, did you skip high school or something? How did you pass your grade 12 maths without knowing this and that and that? Okay, that's why you need to be guided correctly. So make sure you follow the notation. You do it the right way. Okay, so this question, right? There are many ways to start. All right, there are many ways. In my case, I'm going to use my knowledge of sets to rewrite this term and that term. Okay, I'm going to eliminate those sets. So my next step will be d of x of this one. I can write it as a half x to the power of a half. Okay, and that one I can write it as 2x to the power of minus a half. I hope everyone remembers that I told you, if you want to find derivatives using rules, your knowledge of exponents and sets is very, very important. Okay, so that's my approach. Another way would be to use FOIL first before removing any sets. You remove brackets using FOIL, and then you simplify. So in my case, I decided to use my knowledge of sets first. So my next step now is to remove the brackets, the circular brackets first. So I'll have a half x to the power of a half plus 2x to the power of minus a half times a half x to the power of a half plus 2x to the power of minus a half. Okay, and then I'm going to use FOIL from grade 9, okay, together with my knowledge of exponents, okay, together with my knowledge of exponents. So if I multiply those two, I'm going to get x, okay, but this will be a quarter x. Okay, because a half times a half, that's a quarter. X to the power of half times x to the power of half, that's x. Okay, then a half times 2, I'll get 1. I'm here now multiplying this up by the 2. Okay, so a half times 2 will give me a 1. Then x to the power of a half times x to the power of minus a half will give me 1. So I'll get plus 1. Okay, so I finish multiplying this by those two terms. Then I'm here now. 2x to the power of minus half times that, I'm going to get another 1. Okay, are you following? Then this 2x to the power of minus half times 2x to the power of minus a half, I'm going to get 4. Okay, now minus a half plus minus a half will give me 0. So I'll end up getting a 4. So it's not a 4. So it's not a 4. I should get 4x. I should get 4 goes plus that. I'll get 4x to the power of minus 1. Okay. So it's 4x to the power of minus 1. Because minus a half plus minus a half gives me minus 1. Okay? And remember, this 4 comes from 2 times 2. It gives you what? A 4. Okay? Any question? Alright. From here now, if I simplify this, I can now find my derivative. You see, these two are constants. So this one becomes, okay, let me rewrite like this. I'll start with that quarter x plus 4x to the power of minus 1 plus 2. So my final answer is going to be a quarter, okay, minus 4x to the power of minus 2. Okay, so it will be a quarter a quarter minus 4x to the power of negative 2.
Does your exponent have to be positive? Or?
Well, in most cases they're supposed to be positive. So, but sometimes when we teach us math, okay, if you stop here, you deserve full marks. But you can write this eventually as a quarter minus 4 over x squared. Okay, but in your case, in this class, I encourage you to leave your exponents as positive integers. Or if they are rational, okay, if your exponents are rational and they are negative, leave them as positives. So convert all your exponents from negative to positive exponents. You have any question? All right. Is there anybody else who's got a question? Okay, so let's carry on to the next question. Next question. That's B in 2B. All right. The question was saying determine dx over dy. Okay, I hope that you didn't get confused there. Now, if it's dx over dy, it means that x is going to be the output variable, it's going to be the dependent variable. Okay? If the derivative is dx over dy, it means x is your dependent variable and y is your independent variable. So what you're supposed to do there, make x the subject. Okay, make x the subject. Okay, so in this case, x is the subject, but we have got brackets there, so we need to remove those brackets. So next step will be x equal to 4 to the power of minus 1, y to the power of 4 minus, I'm going to introduce a square bracket, because I want to use FOIL here. So I'll have y to the power of minus 1 minus y times y to the power of minus 1 minus y, and then close bracket. So this becomes x equal to 4 to the power of minus 1, y to the power of 4 minus, open square bracket. Now, here, you have to add the exponent. So if you add, you get y to the power of minus 2. And then there you will get minus 1, because the exponent of this y is a 1. So minus 1 plus 1 gives you 0. Y to the power of 0 is 1. Again, these two will give you another minus 1. And then you get plus y squared. Okay? So before I find the derivative, I need to make sure that my exponent, okay, I'm going to rearrange them and write minus y squared, okay, minus y to the power of negative 2 minus 2. Oh, sorry, plus. That will be a plus. Why are you confusing me now? Okay, so let me check it on my own. So this one here becomes negative, this one is negative, that one becomes a plus 2. Okay, so when you get to this point, you can now find the what? The derivative. When you get to this point, you can now find the derivative. So it will be dx over dy. Dx over dy. Okay, remember, our independent variable is y. So this 4 times the 4 to the power of negative 1, that will give me 1. Okay, it will give me 1. 4 times 4 to the power of minus 1 will give me what? 1. 1 times y to the power of 3, so you will get y cubed. Okay, get y cubed. Okay, if you have got a question, feel free to ask. Remember, I said your knowledge of exponents is required. So 4 to the power of minus 1 times 4 will give you 1, so you end up with y cubed. Then that will be 2y, and that will be plus. It will be minus 2y, that will be plus, sorry. It will be 2y, that will be plus 2y to the power of minus 3. And then, if I want, I can rewrite that one as a positive exponent. So you get y cubed minus 2y plus 2 over y cubed. That can be simplified further, but I don't want to go there. Right? I'll stop here. If you want, you can simplify it further, but I'll stop there. So, that would be your answer. How many of you got something like that? Thank you very much. The last one. The last one. Okay, if you made a mistake, then you need to correct your mistake. But be careful of exponents. Be very careful of exponents. The last question. The last question. Okay, 3C. Right here, you are told that 4t squared minus 2tr plus r minus 1 equal to 0, and you are requested to show that dr over dt is equal to 2. Okay, so you have 4t squared minus 2tr plus r minus 1 equal to 0. Okay, you are supposed to show that dr over dt is equal to 2. Okay, I'm not sure how you approach it, but in my case, I'm going to rearrange and make r the subject, because our derivative is supposed to be dr over dt. Okay, which means we need to make r the subject. Okay, we need to make r the subject. So first thing, I'm going to take all the terms that don't have r to the right hand side. Okay, so I can, and I'm going to rewrite the terms in r in such a way that I'll start with r then minus 2tr is equal to 1 minus 4t squared. Okay, that's my first step. Why am I doing this? Because I need to make r the subject. Our r is our dependent variable, so it must be on the left-hand side of the equal sign. It is the output variable. Okay, then here I have to factorize. So I'll take out the r. Okay, now the moment you create this binomial, it should give you a clue that, okay, on the right-hand side, I need to probably do the same. So I'm going to factorize. There is a difference of 2 squares. Okay? Then I'm going to divide both sides by 1 minus 2t. If I divide, I'll get r equal to 1 minus 2t times 1 plus 2t all over 1 minus 2t. So you can all see that these two will cancel out, and then you end up having r equal to 1 plus 2t. Therefore, dr over dt is going to be equal to 2. Okay? Right? I need you to be aware that it's not always the case that you are going to get expressions or equations that have got x and y. Sometimes you can have other letters, like in this case. But the concept still applies. You need to identify the variable which replaced y and the variable which replaced x. Okay? And then you find your derivative. Then, but you got a question? Okay, if you don't have a question, then this will be the end of rules of differentiation. We are going to use them a lot from now on. All right?